What's going on, guys? Alright, so we've been talking about transformations. That's what Module 2 is over. We had a video already on translations, and we're going to talk about the next type of transformation now called reflections. Alright, so when you think reflections, you might think of a mirror, and that's a good thing to think about because it's very similar to what we're going to be talking about today. Alright, so basically with reflections, you're going to reflect points or objects across. Could be the x-axis, the y-axis, or it could just be a specific line that they might give you to reflect it over. So let's just remember a little bit about some stuff in Algebra 1 that we might have talked about that's going to be useful for this. What does the graph of each of these look like? X equals 3 and y equals 3. So one thing that you want to make sure you remember about any equation that is an x equals equation, it's going to be a line that goes straight up and down. Alright, that's not exactly straight up and down, but any x equals line is going to go straight up and down vertically, and a y equals line is going to go left to right horizontally. Okay, so one way you can remember, might help you is this is the x-axis and this is the y-axis. So if it's an x equals line, the line has to cross over the x-axis, okay, at the point that it tells you it equals. So since x equals 3, then we got to have a vertical line that crosses over where x is 1, 2, 3. So this is going to look like a vertical line, make it as vertical as I can, straight up and down like that. So at y equals 3, it's the exact opposite. It's going to be a horizontal line crossing against the y-axis, crossing to the y-axis up at 1, 2, 3. So we're going to have a horizontal line, going in both directions forever across the axis at y equals 3. Alright, so just some stuff to remember from Algebra 1. Alright, so some types of reflections. Reflecting a figure in a line. So to reflect a figure, you draw a line that cuts the figure in half. Okay, if you folded the figure along the line that you made to cut it in half, then the two parts should overlap perfectly, okay? And you've probably heard this called a line of symmetry in the past. Alright, so for example, this right here, this butterfly, it's got a line of symmetry, or reflecting line that goes right down the middle of it. Again, that's a little bit off, but maybe I can move that line for us. So yeah, that line would go right down the center of that butterfly, and you can see it's the same on both sides. Okay, this star has a lot of different lines of symmetry. You've got one that goes right down the top. You could even do one going up this way, one down that way, one this way. There's a lot of different lines of symmetry on that star, but that's an example of one. See, it's exactly the same on the right side as it is on the left. And then you can see this seashell right here has another line of symmetry going up and got a little curve in there at the end, but you get the idea. It's going to cut it in half and be the same on the left as it is on the right. Okay, so those are reflecting lines or lines of symmetry. Okay, so now let's talk about if we reflected a point over a specific line. Okay, so this right here says reflect A over the y-axis. So this is our y-axis right here. So let's go ahead and just retrace this line as close as I can. It's very curvy. That is very bad. I want to erase it and try again. Even though I know you guys probably know what I'm doing. That's just unacceptable. But this tablet is tough to draw, and I'm still getting used to it. Maybe if I try it quicker, I can get it. There we go. It's a little bit better. Okay, so that's our line. We're going to be reflecting across that line. That's like, imagine that's like our mirror. Okay, so we want things to be the same side, or the same on both sides of our mirror. So the easiest way to do this is to just count how many spaces from the reflecting line the point A is. So we can see it's 1, 2, 3, 4 spaces. So then if we're reflecting it, then the point that reflects A should be that many spaces away on the other side. 1, 2, 3, 4 spaces. And of course, as you remember from the last video, the new transformation we make, we're not just going to call it A, we're going to call it A prime, right? So there's a reflection of A over the y-axis. Now this says reflect A over the line x equals 2. So this is a little bit different. It's not going to be the axis, it's going to be a line x equals 2. And as we remember from the slide a minute ago, x equals equations are vertical lines. So we're going to make a vertical line that crosses the x-axis at 2. Hopefully we can make a good one. Yeah, it's not too bad. Alright, so there is our x equals 2 line. So since we want to reflect over this line now, not the y-axis, but the line x equals 2, we've got to count how many spaces this point A is from the line x equals 2. So we can see it's 1, 2, 3, 4, 5, 6. So then when we reflect it, it's got to be 6 across the other side. 1, 2, 3, 4, 5, 6. So right there is our A prime. Alright, so a little bit different right there because it's not the axis, it's a specific line x equals 2. Let's roll on. Alright, so another situation that you might have to reflect is reflecting a line across the equation y equals x. So instead of it being a perfectly vertical line or perfectly horizontal line, alright, it could be a line like this. This is the line y equals x. So it's always going to go diagonally, perfectly diagonally, up through the origin, and yeah, right there's a good example of y equals x. Okay, so if we want to reflect across this, you can see right here it says, in order to reflect over this line, both the x coordinate and the y coordinate are switched, so they just swap places. So below it says reflect the following points along the line and write the new coordinates. So I'm going to show you this first one. A is 2, negative 4. So we go over 2, down 1, 2, 3, 4 to plot the point 2, negative 4. That's A. And then it switches to A prime. So if we're reflecting over the line y equals x, see the x coordinate and the y coordinate just swap places. So the A prime is going to be the coordinate negative 4, positive 2. Right there is our A prime. Okay, so we just swap places and then graph the point, and notice they reflect across the line y equals x. So I'm going to go ahead and pause the video real quick and let you guys practice B, C, D, E, F, and G. Here's what your paper might look like once you practice these. I know you might not have had enough room to do some of these, and the graph obviously doesn't go far enough to put every point on the graph, but you kind of use your imagination and pretend you're counting a couple more squares out to put the rest of these points. So as you can see, you've got your B and B prime were basically just the opposites of A and A prime. So those were the same 2 points, just A prime was B and B prime was A. So then C and C prime, you can see they're reflected, D and D prime, and then you got F and F prime. See, I think I left E off, so let me do that one real quick. So if it was 6, 0, and then 0, 6, and that would be those two. So then this one would be our E, and this one's E prime. I forgot that one. So yeah, you can see those are reflected, and the F's and the G's, so they're all reflected across that line y equals x. Now one thing to be aware of is if the point was, say, something like 2, 2, okay, and it was right on the line, well, whenever you swap your x and y's, you're just going to get the same point again. So any point that's on the line that you're reflecting over is not going to move. It's just going to stay on that exact same point. Okay, so just something to be aware of. I don't want you to confuse you later on whenever you get to one like that. All right, now let's keep on cruising. All right, so now we got to actually write a rule for these reflections. Okay, so essentially the rule for these is going to be something like reflect over and then the line that we're reflecting over. So right here we would say reflect over. Okay, so now let's see what are we reflecting over. So you've got J prime and J right here. So obviously the reflecting line must be between these 2 points, and it must be between E and E prime and P and P prime. So we can see that midway between these 2 points is right here. So this right through here is our line of reflection or our line of symmetry. So the question is, how do we represent that line? Well, it's a horizontal line, and as you remember before, horizontal lines are represented with a y equals, and then whatever point on the y-axis the line is crossing. So that line is crossing the y-axis at -1, -2. So we would say reflect over y equals -2. and that will change the black triangle into the blue triangle if we reflect over the line y equals -2. Alright, so let's go down here and do this other one. So right here we've got the triangle ZXT and Z prime X prime T prime. So we got to determine, how did these reflect? They reflected over what line? So we know they reflect over, or you can say reflection over, but either one's fine. So what we got to determine is, where's the middle? So we got X and X prime, but where's the middle of these 2 points? So let's count how far apart they are. 1, 2, 3, 4, 5, 6 apart. So then halfway between them would be 3 apart, of course. So we're going to say 3 from X, 1, 2, 3. Alright, so right here is our middle. So they're going to be reflecting over this line right here. Well, that line, as you can see, is our x-axis. So we don't need to say y equals something. We can just say reflect over the x-axis. Okay. Anytime it's reflecting over the x-axis or the y-axis, you can just say reflect over the x-axis or reflect over the y-axis. But if it's one of these other lines like this, then you're going to have to say y equals a number or x equals a number. So I'm going to go ahead and pause it and let you guys practice doing this with problem 3 and problem 4. Alright, good luck. You can see here on this one, our line of reflection halfway between S and S prime and halfway between Q and Q prime and so on is this dotted green line right here. So we would say reflect over y equals -1, because that line's going through the y-axis at -1. And then number 4, this one reflects left to right. Okay, so it's reflecting across a vertical line in between R and R prime, which is this vertical line right here. So vertical lines, we would say reflect over x equals, and it's going through the x-axis at -2. So we'd say reflect over x equals -2. Alright, now the last slide right here, and we'll be done with reflections. Okay, so now we actually have to draw the new image. We're not going to write the rule. They give you the rule and give you one image, and we have to create the transformation ourselves. Okay, so they say reflect across the x-axis on this one. So what we want to do is identify where's the x-axis. Well, that's this right here. So let's go ahead and draw that. It always make it easier if you will draw your line of reflection, whatever they tell you it's going to be. Okay, so since we've got to reflect across this line, it's going to be a little tricky because some of our points are above it and some are below it. So some of our points are going to reflect to the bottom, and then the other points on the bottom are going to reflect to the top. Okay, so it can be a little bit strange when you've got them flopping past each other and all that. So let's do A first. So how far is A from our line of reflection? Just 1. So we're going to put A prime 1 away over here on this side. I'm going to label that A prime. And then we're going to reflect U across the line. So U is on the bottom side of the line, 1, 2, 3, 4 away. So we're going to put it 1, 2, 3, 4 away from the line on the top. So this is my U prime. And then G is 1 below, so we're going to reflect it to be 1 above. So that's G prime. And then T is 1, 2, 3, 4 below also, so we're going to reflect it 1, 2, 3, 4 above. And that's T prime. And then we can draw our new shape. That was really, really bad, but you guys got the idea. So I can straighten it out a little bit. That's a little bit better. So we got this shape right here. This four-sided figure is our reflection of figure AUTG. All right. And then let me go ahead and do one of these other ones. So number 6 says reflection across y equals -1. So let's draw the line of reflection. Y equals -1 is going to be a horizontal line that hits the y-axis at -1. So right here's -1, and it's going to be horizontal, so it's going to be right through here. Okay, so we've got to reflect the points across that line. As we can see, S is 1 below, so we're going to reflect it to 1 above. And that'll be S prime. T is 1, 2, 3 above, so we're going to reflect it to 1, 2, 3 below. Here's T prime. and then X is 1, 2, 3 above, so it's going to be 1, 2, 3 below. Don't you wish there was a letter Optimus, so you could say Optimus Prime when you did this? That'd be cool. So I is 1, 2, 3, 4 above, so we're going to put I prime 1, 2, 3, 4 below. Alright, and then we connect our points. Connect I to X, I to T, S to T, and X to S. That was a lot better. Okay, so you can see this is our reflection across the line y equals -1 on this shape. So I'm going to go ahead and pause it and let you guys do 7 and 8 for practice. Alright, so you can see right here, if reflecting across x equals -2, that's a vertical line crossing the x-axis at -2. And you've reflected z 1 space, r is 2 spaces across the line, and n is 3 spaces across the line to give our new triangle n prime r prime z prime. And then number 8, reflection across the y-axis. So our reflection line was exactly right on the y-axis. Notice v was on the axis, so it didn't have to move at all. This is actually our v prime also. V and v prime in the same place. Y prime, and then w prime down here. Okay, so that's reflections, and hope you guys understand these now. If you have any questions, raise your hand, let me know.